So we're solving for x. Multiply both sides by x plus 5. X plus 5. So 8 is less than or equal to 4x plus 20. We want to isolate our x, so I'm going to subtract 20. So then we have negative 12 is less than or equal to 4x. Divide by 4. So then we have x is greater or equal to negative 3. So for step 2, we want to consider the sign of the least common denominator, which is positive. So then we're going to say that x plus 5 is greater than 0. If we solve for x, we get that x is greater than negative 5. Once again, we have two possible solutions, so we want to test them. So for x greater than or equal to negative 3, I'm going to test x equals negative 2. 8 over negative 2 plus 5 will give me 8 over 3. Is it less than or equal to 4? True. Okay, now let's test the value for x is greater than negative 5. What did we test? X equals negative 4. So 8 over negative 4 plus 5 will give us 8 over 1, which is just 8. Is 8 less than or equal to 4? That's false. So for case 1, we have one solution. X is greater than or equal to negative 3. Now let's do case 2. So once again, we want to solve for x. Remember that our least common denominator is negative. So when we multiply by a negative value, we have to reverse the inequality. So now we have 8 is greater than or equal to 4x plus 20. Once again, we want to isolate our x, subtract 20. So we get negative 12 is greater than or equal to 4x. Divide by 4. So then we have that x is less than or equal to negative 3. That's one solution. For step 2, we need to consider the sign of the least common denominator, which is negative. Therefore, we're going to say that x plus 5 is less than 0. We solve for x, we get that x is less than negative 5. Once again, we have two possible solutions, and we need to test them. For x less than or equal to negative 3, I'm going to test when x equals negative 4. Once again, you go back to the original inequality. So if we have 8 over negative 4 plus 5 less than or equal to 4, we get 8 over 1, which is just 8, less than or equal to 4. It's false. Okay, now let's test the value for when x is less than negative 5. What if we test x equals negative 6? So then we have 8 over negative 6 plus 5, which is going to give us a negative 1. Less than or equal to 4 is negative 8 less than or equal to 4. That's true. Therefore, the solution set of the original inequality is the union of the solutions to both case 1 and case 2, which is going to be x is less than negative 5 or x is greater than or equal to negative 3, which we can write using set builder notation. The set of all x's such that x is less than negative 5 or x is greater than or equal to negative 3. I'm going to do another video going over some more complicated problems. If you need extra help, you should watch that video.